So I've been getting a lot of questions on the projectile motion problem, specifically page 40, number 3. Now this is your more difficult type of problem, and the reason why is because we have a projectile that is being launched at a specific spot but falling at a spot below. So let me just draw this out so that you can see. It says here that in a children's story, a princess trapped in a castle wraps a message around a rock and throws it from the top of the castle. So what's happening here is we have a spot at the top of a castle. There's an initial vector that I believe is, let me just check here, it's 12 meters per second. And the angle is 42 degrees. So this is being launched at this velocity and this angle. The rock lands on the other side of the moat at a level 9.5 meters below the initial level. So this is part of a castle. Let's draw this up here. You don't have to draw your pictures like this, but I thought might as well. Then we have a moat. The projectile ends up falling at a spot that would be at the end of the moat. So this is right where the moat ends. Here we have regular ground. And this is 9.5 meters. The distance that it falls here, 9.5 meters below that initial level. So this is that more difficult type of projectile motion problem. We have a initial vector that's at an angle, and we have our rock or our projectile falling not at the same level as at which it was launched, but at a level below that. So in order to solve the three problems here, first one is calculate the time of flight, the width of the moat, and then the rock's velocity upon impact. The key part here is finding out what 3A would be. So for 3A, this is the time of flight. Let's list what we have that's given to us. We know, and in terms of finding the time of flight here, we're not interested in the x. We'll find it in the y direction. So we know that our VIY is equal to 12 sine of 42 degrees. We also know that our dy, our final displacement, is negative 9.5 meters. And our a, this is the important part, our a is negative 9.8 meters per second squared. So why did I write this as a negative? Sorry, I'm going to move this over. I wrote this as a negative because we're going to take our down direction as a negative and our up direction as positive. So given all that information, I need to figure out which equation to use that'll help me solve for t. And the best equation to use here would be dvit plus at squared over 2. Keep in mind that I'm going to write all of my negatives in appropriately. 12 sine 42 degrees. This is a t. Then I have plus negative 9.8 over 2 t squared. I'm then going to resolve this and move everything to the other side. So let me just write 0 equals, this will be positive 4.9 t squared, negative 12 sine 42 degrees t, negative 9.5. Now, this would have to be solved using the quadratic equation. So t equals, this term becomes positive, so I'll write 12 sine 42 degrees plus minus the square root of 12 sine 42 degrees squared minus 4, oops, let's move that a bit too much, times 4.9 times negative 9.5. Now this should technically be negative. The negative is going to go away. this entire thing divided by 2 times 4.9. That is my set of solutions. Now when you resolve this, you'll end up with two answers. And I'll write a few decimal points afterwards. 2.4349 and negative 0.7962. A negative time is not relevant in this case. So my time is 2.4 seconds. That's my solution for this problem. Now I'm just going to slide over this way. I'm going to answer 3b. So for 3b, this is the question where we're asked to calculate the width of the moat. So that moat goes right up to the tower, all the way to there. So this is essentially the range. We're looking for what is dx in this case. That's my unknown. And my given information, my vx, initial and final are both the same, is going to be 12 cosine of 42 degrees, meters per second. My t, I'm going to write this down as 2.4349. I'm going to keep those extra numbers just because it's important to have as many decimal points as possible when solving these questions, just in case they have an effect. And my d is what I have to solve for. So actually, yeah, this is rather simple. It's just dx equals vxt. So 12 cos 42 degrees times 2.4349. You'll end up with 21.71, 22 meters. That's my solution for that. Now last I have 3c. Determine the rock's velocity on impact with the ground. So with this case, to find the rock's velocity on impact with the ground, let me rewrite my givens. We have VIY, which we already know is 12 sine 42 degrees meters per second. We know our A, negative 9.8 meters per second squared. We know our dy, negative 9.5 meters. Now we could use our t to help solve for this as well, but it's best, because this was a calculated value, it's best to use these values here, so that way we don't have to use any trailing decimals. So given this information, what I need to find is what is my VFY. So this is what I need to calculate in order to calculate my my other information, because my final velocity is going to be a vector addition of these two velocities, the VFY, which we need to calculate, and the VFX, which we know because that's the same as our VI initial, or sorry, our VIX. So for VFY, to find this, let me see here. What I would need to do is find my, it's equal to the negative, well actually not the negative, but I'll tell you why I'm doing that later, square root of let's see here, VIY squared. Oh, that's the equation I'm using here. So I'm using this equation here. Let me just rewrite the equation. V2 squared equals V1 squared plus 2AD. So using that equation, I'm just rewriting it here. So VIY squared plus 2 times negative 9.8 times negative 9.5. This becomes negative square root of 12 sine 42 degrees squared plus 2 times 9.8 times negative 9.5. And the reason why I'm writing this negative is because this will give me two answers here. And one of them is going to be 15.8327 meters per second. The other is going to be positive 15.8327 meters per second. I have to take the negative value because this is going to be essentially this is going to be moving in the downward direction. So my my velocity is going down, so I have to take a negative. Now going back up here, my VFX is that value. I need to find out what's my VF. So this is the square root of VFX squared plus VFY squared. So that equals the square root of 12 cosine of 42 degrees squared plus negative 15.8327 squared. My VF ends up becoming 18.17 meters per second. To find my angle, I'm going to use the inverse tangent. Let me actually, to find my angle, let's do this here. I'll draw out my triangle on the side. So I have a velocity vector going to the right and one going down. And I need to find out what this angle is here. So if I find the inverse tangent of the y over the x, that would be 15.83, just take that, over 12 cosine of 42 degrees. Sorry, I'm running out of space here. That ends up becoming, I'll rewrite this, that ends up becoming about 60.6. Sorry, let me just recalculate that. Yep, 60.6, which becomes 61 degrees. So my final answer, VF equals, I have to round for significant digits, 18 meters per second at an angle of 61 degrees below the horizontal. Now I know your textbook says 60 degrees. I prefer you use the exact values throughout. This should be your final answer for C.